All right, chapter 7. This one's pretty quick. We're just going to talk about input validation. And what that is, basically, just a short summary of input validation, is whenever you get any sort of input from the user, so any data that you receive, your program receives from the user, you have to make sure that it is correct and that it is in the format that you want it to be. So for example, if you ask your user to enter their name and they will enter, I don't know, like a number, their age or something, like 27. Of course, you don't want that, and you have to make sure that your user is aware that that input is not acceptable, and so that input doesn't go further into your code, and then it will cause problems. So for example, if your program expects user's name and instead of their name it gets a number 27 or whatever number that is, that will cause many problems down the line. So that is what input validation in summary. These are all the topics that we're going to cover today. There's not that many of them. So yeah, garbage in, garbage out. That's the concept that you should be familiar with. Garbage in, garbage out. That just stands for an idea that when your program reads any input that is bad, it will produce output that is also bad. So what that means is, as I mentioned before, with the name and the age, for example, if you want your user to enter their name, right? For example, we have a program that just reads user's name and then shows it back to them. For example, it asks enter your name, and then the next code that it's going to produce is going to be your name is whatever their name is. So for example, if you get your user to type something else that's their name, that's not their name, they're going to type, for example, as I said, a number 27. I don't know why I'm so stuck on 27. But for example, you ask your user to say enter your name, right? And instead of, for example, typing Sonia, me as a user, I would put 27. And then after that, we want to produce your name is with whatever the user inputted. And instead of Sonia, it's going to be your name is 27 because I entered 27. Well, that doesn't make any sense. And that's just on the most basic level of programming, on the most basic idea of bad input, bad output. So you just want to make sure that your user types exactly what you want them to type in the format that you want them to type. And that is where input validation comes in. So all of the input, any input that your user gives you, you have to make sure that it is checked. And you have to make sure that you inspect that input before you continue moving on with working with that input. If that input is not correct, what you have to do as a coder, you have to implement input validation, and you have to reject all of the bad input that comes into your program. So if the user, for example, in this case, if the user typed enter your name and they typed 27, instead of just proceeding with that 27, what has to be done, let me show you. So for example, they type 27. Instead of proceeding with 27, what you have to do, you have to make sure that you print something like input not valid, input not valid, then period, enter your name. So you have to ask the user again to enter their name. And that has to happen until the user actually types their name. Okay, so you have to make sure that you indicate to the user that 27 is not accepted. You have to type your name. So that is the whole idea of input validation. You just have to make sure that you check everything that comes into your program from the outside. Now, here is a little example of a program without any input validation. So this program is just in pseudocode. So what we have right here on the third line, we are declaring a couple of variables that's going to store hours that the person worked, then the pay rate that they have, and the gross pay, what they earn. Then after that, we're going to ask the user, enter the number of hours worked on line 6 right here. We're going to ask them, enter the number of hours worked, and then we're going to store that number that they entered in hours. Then after that, we're going to display enter the hourly pay rate. So we're going to ask the user to enter how much money they earn per hour, and we're going to store it right here in pay rate. After that, we will be calculating the gross pay. So we're just going to multiply hours by pay rate. And after that, we're going to display the gross pay is whatever the calculation produced. So this is the output right here that's going to be produced from your program. Enter the numbers of hours worked. In this case, they entered 400. Then enter the hourly pay rate. In this case, they entered 20, and the gross pay is $8,000. However, if your user inputted anything other than a number for hours and pay rate, if they entered their name, or if they entered no, or if they entered yes or zero, that would cause a problem, because in programming languages and in most programming languages, you cannot multiply words with numbers, right? So that would cause a problem, and that would cause your program to crash. So that is why this is a perfectly fine program. It works as it intended. However, if your user types anything else other than numbers, that will cause your whole code to crash, and your computer will not continue with the execution of your program. So this program is without any input validation. Now, this is just a little diagram to show you what's the logic behind the input validation loops. Let's see. So we come in right here and we get some sort of input from the user right here. And then we ask, is the input valid? If the input is invalid, so if the input is bad. If it is bad, we follow this arrow right here. We're going to display an error message, and then we're going to get the input again. And after that, we come back all the way to our question again. Is the input bad? And if it's still bad, we're just going to repeat this whole process again, and again, until the user gives us something good, something that we can work as. If the input is not bad, we're just going to continue with the execution of our program. Let's see. Another term that you should be familiar with, priming read. Priming read is very simple. It's just the first input that comes into your program. So the first thing that the user enters, that's what's called a priming read. And in this case, we have a test result program, a little test result that shows us that prints the user's test score. So we're asking them to enter a test score right here. Then we're going to store that score in a variable called score. And then we're going to make sure that that score is valid. So it has to be between 0 and 100. So what we're checking with this while loop right here, we're checking if the score is less than 0 right here, or the score is greater than 100. Because in both of those situations, our score is invalid, right? Because it cannot be less than 0, and it cannot also be more than 100. And then if that is the case, if the user enters an invalid test score, we're going to display an error. The score cannot be less than 0 or greater than 100. And then we're just going to ask them to input the correct score, and then we're going to store that score again in a value, and we're going to come back all the way to the beginning of our loop. And we're just going to keep going until the user gives us a score that is in between 0 and 100. Okay. Sometimes you can also write validation functions, and functions are in chapter 6. I think that's the functions chapter. So those are just the same idea. You just use them for validating your input. However, those are mostly used in large programs. So if you have 300, 400, 500 lines of code and multiple inputs that you need to check, you might want to write a validation function. And what that is just a piece of code that is separate from everything else. So it's separate from all of your other code. And that function works specifically to check if the input is correct. So usually that function is a Boolean, and a Boolean data type, let's do a little recap. A Boolean data type returns either true or false, only two values that can be returned from the Boolean variable, either true or false. So how the validation function mostly work is that it's going to check the input, is going to make sure that it's good, or is make sure that it's bad. And if it's good, it's going to return true, which just stands for yes or accepted. And if it's bad, it's just going to return false, which stands for no or not accepted. Let's see. See next. The concept of defensive programming. So defensive programming is you as a coder knowing that the errors can be prevented and you trying to prevent those errors before they even happen. So basically, input validation is a part of defensive programming, and that is just the way for you to anticipate both errors that can happen or errors that you don't think that they might happen, but still like unobvious errors. That is the defensive programming. So you're just anticipating all of the bad thing that can happen with your code and you're preventing them before they even happen. Now, there's a couple of errors that are pretty common with input, and you have to be aware of those. Those are pretty easy to memorize because they're just common sense. So if user just accidentally hits enter before entering anything, right, that's called empty input. So if they don't enter anything into your program, you have to be aware that that might happen. User just, accidentally presses enter. That is one thing that you should be aware of. And another thing that's very common is user entering the wrong type of data. As I mentioned, if you ask them for a name and they give you a number. Another common error, so state abbreviations usually are 2-character strings, right? If the user tries to type a full state abbreviation and your program only accepts the short version, the 2-character strings, you should let the user know that they need to type the state with just 2 characters, not the full name of the state. Then zip codes are either 5 or 9 digits. So that is also a thing that you need to take care of and let the user know that their zip code needs to be either 5 or 9 digits. Then hourly wages and salary amounts are numeric values and within a certain range. So not less than 0 and not more than, a certain like obnoxious amount, like hourly wage of 1 million per hour, right? That usually does not happen. Then you should check the dates for those dates to be from real time or within a certain amount of time. For example, if you're asking somebody for a date of birth and they give you a date of birth in the future or a date of birth from 1800s, you know that it's not the correct date of birth, right? So you have to check for that. Then time measurements. Also another thing, if you ask the person how many hours they worked in a week and they give you like a number of 300, that's not possible. So you should check for that. And just the same idea comes with the checking for reasonable numbers. For example, somebody's age, how many hours they worked in a week, and so on. Just make sure that whatever you ask your user to enter, that it is in the realistic range, right? That's the whole idea of defensive programming. Now, here's a little program. This is the last thing that we're going to look at today. This is a little program in Python that's going to calculate the retail prices. And then we also have a variable called markup that is a global constant. And a recap for what a global constant is just a variable that will not be changed throughout the execution of your code. So we have a markup variable that equals 2.5. It's going to stay at 2.5 throughout your whole program. This variable will not be changed. That is the global constant definition. So we have 2.5, and then in our main function, what's happening, we have a loop right here. We have a loop that only works if this variable another is equal to y, which stands for yes. And here's our input validation right here. As you can see, we're checking while our variable another equals to y or capital Y, which both stand for yes, we're gonna display an item's retail price. I will show you the function for that on the next page. So we're gonna display an item's retail price, and then after that, we're simply asking the user, do you have another item that you want to look up their retail price? Enter Y for yes, right here. Enter Y for yes. So if the user enters anything that is other than Y, we will just stop executing our program. But if the user enters Y, we're just going to display another item's retail price. And we're going to do that until our user stops typing Y. And let's look at the next page. This is the function for the actual showing of the retail price of the item, right? So what we're going to do, we're going to ask to enter, we're going to ask the user to enter the item's wholesale cost right here. We're just getting, I know it looks a little bit different probably because there's a lot of code, but you just need to know the general idea. You don't need to know how to write this, just the general idea of what's happening. So we're going to ask the user to enter the item's wholesale cost right here, and we're going to store it in the variable called wholesale. Then after that, this is where the validation comes in, the input validation. We're going to make sure that the wholesale is not less than 0, because if it is 0, then the price is not right, because the price cannot be less than 0. So we have to make sure that it's not less than 0. And then if the user tries to enter a negative number or 0, we're going to print an error. The cost cannot be negative. Enter the correct wholesale cost. So this is an example of validating users' input. Pretty simple, so nothing too complicated. As you can see here, this is the program output. If the user prints a negative number, in this case, negative 50 cents, we're going to print an error. The cost cannot be negative, and then we're going to ask them to print the correct wholesale cost, which they enter the right number, 50 cents, and then we say the retail price is $0.25. And then we ask, do you have another item? Enter Y for yes. They enter N, which stands for no, and our program just stops executing. All right, so that's it. That's all I had for today. Let me stop sharing and stop recording.